Alright, so let's return to our discussion on C3, C4, and CAM plants, and these are just sort of different alternatives in photosynthesis that allow for some different outcomes preventing water loss. And so we already talked about C3 a little bit towards the beginning of the last video, and sort of the point that I was trying to get across there is that in the Calvin cycle, in that first step of carbon fixation, we're taking carbon dioxide, which is just one carbon attached to two oxygen, right? And we're fixing that into a 3-carbon compound, and that's why we call it C3. There's 3 carbons, and so C3 photosynthesis is sort of the norm in terms of how the Calvin cycle works. So most plants are C3 plants, and if you look down here, the picture's kind of cut off. This is a very Indiana example, though. Soybeans are an example of a C3 plant, and so they close their stomata to conserve water when it gets hot, and sometimes as a result, photorespiration might happen. And again, photorespiration, it's ironic that I use the cookie example because I'll tell you, I've tried to make chocolate chip cookies once and it was a disaster, but we're just going to roll with that example throughout this video. And again, photorespiration is changing the starting ingredients. So instead of using carbon dioxide, they're going to use oxygen from the atmosphere to create those sugars in photosynthesis. And so my example was, instead of using sugar in your cookies, you're going to substitute it for salt. And obviously that would be disgusting, but that sort of gives you maybe a view of how photorespiration is bad for the environment, because we're taking that carbon dioxide, or the oxygen rather, out of the atmosphere, and instead replacing it with carbon dioxide. When we, as humans, we need that oxygen that plants are producing. So photorespiration hurts us in the long run. So that brings us to our first alternative route of photosynthesis, C4. And if you get out your best friend little handout that Mrs. Vale has made for you guys, you can see on the bottom left it talks about C4, and it says the words mesophyll and bundle sheath cell. And so the mesophyll cell, that's where the carbon cycle, the Calvin cycle, usually takes place, in the mesophyll cell. However, for C4, they kind of break things up so that they make a 4-carbon compound instead of a 3. That's one difference between C3 and C4, making a 4-carbon compound in the mesophyll cell. And then they transfer that 4-carbon compound to the bundle sheath cell, so an entirely different type of cell. And then that's where they're going to carry out the rest of the Calvin cycle and the rest of those steps, so that we're ending up with our final product of sugars. So with this, and sort of using it and the analogy I've created here, say I don't have sugar at my house. Well, a C3 plant would say, well, whatever, we're just going to use salt instead. But a C4 plant kind of cleverly takes a different strategy, and the C4 plant would be like saying, I don't have any sugar at my house, so I'm going to go to my neighbor's house and I'm going to go make the cookies at my neighbor's house because they have sugar. So for me, I live in a duplex. That's kind of the house type that I live in, and actually my landlord lives in the other half, so he's a super nice guy, and maybe I just don't have sugar. I'm sure that he would let me borrow some sugar. He's a nice guy, and so I'd go over there, and that's how we would do it, and that's how we'd make the chocolate chip cookies. So C4 plants avoid photorespiration, and they use a different route to concentrate carbon dioxide and produce 4-carbon sugars. So C4 plants, as a summary, they're using a physical separation of fixing carbon and completing the carbon cycle in different locations: the mesophyll cell and the bundle sheath cell. So that's how C4 works a little bit differently. But there's one more way that plants can do this. And some plants, and especially in dry, arid environments, they use CAM as a strategy of separating based on time when certain processes take place. So CAM plants are going to open their stomata at night, and the reason they do this is if you're in a very dry environment, it's easy to lose water. And so during the day when the sun's beaming down in the desert, say, you're going to lose a lot of water if your stomata are open, and that's going to hurt the plant. They need that water to survive. So they close their stomata during the day so that they don't lose all their water, and they open it in the night when it's cooler, and that's when they're able to suck in the carbon dioxide to complete this process. So during the day, the carbon is stored as an acid, and the acid is broken down to produce the carbon dioxide for photosynthesis. And then at night, they bring in carbon dioxide. And that's sort of how it works for a CAM plant. And I'm going to be honest, the analogy kind of breaks down a little bit here, but here's my best attempt at making the cookie analogy fit into this. So say I'm too busy to get my groceries, my ingredients for the cookies during the day, so I have to go to Walmart, and I have to do that in the evening because I'm working all day, and I come to Homestead sometimes, and I've got a few jobs and classes and all that stuff, so I just don't have time to get my ingredients, so I have to go to Walmart in the evening, and then I guess I can bake my cookies in the morning. So that, maybe was a little bit weaker than the other examples. But the point is that CAM is using temporal separation, so a change in the time that they're doing different processes in photosynthesis. And this differs from C4, which is using physical separation, so doing bundle sheath cells and mesophyll cells, different locations. And that would be kind of the main difference, I would say, between C4 and CAM to help you remember. C4 happens in 2 different places, CAM happens at 2 different times. Alright, and so this wraps up the second video here, and in the final video we're going to talk more about photorespiration.